Well, hello, Year 8s, and here we go for again another video, exercise 2D this time, where we're looking at quadrilaterals. Okay, again, a little bit more of a review from Year 7, maybe expanding our knowledge a little bit on that one, but yeah, nothing you haven't really seen before. Alright, so what are quadrilaterals? They are four-sided shapes, and they have four interior angles. Okay, as you can see here, so 1, 2, 3, 4 interior angles, and 1, 2, 3, and 4 sides. All quadrilaterals have the same angle sum, and we'll get to that in a minute, but other properties can depend on other things such as how many pairs of equal sides there are, parallel sides, and lengths of diagonals. So we'll cover all that very, very shortly. All quadrilaterals can be drawn as two triangles. So as you can see with this quadrilateral, you can actually split them up into triangles. As you can see there, there's triangle 1 and there is triangle 2. All right, and since the 6 angles inside the triangle make up the 4 angles of a quadrilateral, so 1, 2, 3, 4, 5, 6, the angle sum of quadrilaterals is 360 degrees. All right, so when you add up all these 4 angles, so 1, 2, 3, and 4, that'll always equal 360 degrees. All right, and that's why you can see it here. So when you split this into two shapes, we've got 3 interior angles here. That'll always add up to 180 because it's a triangle. Another triangle over here. That adds up to 180. So 180 and 180 gives us 360. All right. Okay, let's move on. Bit of information about quadrilaterals, and again we've covered a lot of this stuff last year. So quadrilaterals can be convex or non-convex. So convex means that all interior angles are less than 180 degrees. I might draw that a little bit better. Okay, so less than 180 degrees. And the other thing about convex quadrilaterals, sorry, is that all the vertices, so again the points of the quadrilateral, will be pointing outwards. Okay, the diagonals of a convex quadrilateral lie inside the figure, as you can see here. The diagonals lie inside of the shape. Okay, non-convex means that there is one vertex, as you can see here. Okay, is a reflex angle, or it's pointing inwards. Okay, so this one angle in a non-convex quadrilateral will always be pointing inwards. Okay, and as you can see with our what are they called, diagonals? You're going to have a diagonal on the outside of the shape as well. All right, so that's a bit of a difference. Okay, so you've got convex and non-convex. Okay, non-convex always has that interior angle, that's a reflex angle, and so it's pointing towards the inside of the shape. All right, so a little bit of information about different types of quadrilaterals. So we have parallelograms. All right, so again, they're quadrilaterals because they've got 4 sides and 4 angles in there. Now quadrilaterals, I'll slow down a bit, with 2 pairs of parallel sides. Okay, so we've got one parallel side over here and one parallel side there that are equal. Okay, and we've also got a parallel side here and here. They are also parallel. Other properties within a parallelogram are that opposite angles, so angle here and angle here, are going to be the same. They are equal. And the angle here and the angle here that are opposite each other are going to be different than these two, but also equal. Okay, so these guys here might be 80 degrees, for instance, and without doing sums in my head, these might be 100 degrees and 100 degrees. Okay, so opposite angles are also equal. The diagonals, as you can see here, we've got the diagonals are different lengths. Okay, so this diagonal is of a different length to that diagonal as well. All right, so that's some of the properties. All right, so you do need to know some of those properties. It might be worth noting them down. We've got some special parallelograms. You've got rectangles, where all the angles inside are 90 degrees. They're all equal, and the 2 diagonals that come through the rectangle are also equal length. We've also got a rhombus, or also known as a kite, and we have done some of them recently. There's a parallelogram with all equal sides. Okay, a square, okay, is a rhombus where all the angles are 90 degrees. So I just lost my way there a little bit. All right, so a square is also a rhombus, but all the angles are 90 degrees. All right, a few more. Other special quadrilaterals that we have are kites. Okay, I did mention that before, and kites are a little bit different to a rhombus, I suppose, in that our diagonals and lengths of our sides are a little bit different. Okay, so a kite is a quadrilateral with two adjacent pairs of equal sides. So that means that these are adjacent to each other and they are equal. Okay, and these sides are also adjacent to each other and they are also different lengths but equal. All right, these two angles here are going to be the same. Okay, they are also equal in a kite. Okay, they are the same angle, same number of degrees. And yeah, obviously our diagonals that cut through a kite are going to be different lengths as well. And then we have our trapezium. Good old trapezium here is a quadrilateral with at least one pair. At least one pair, they can have two, but at least one pair of parallel sides. So as you can see here, that's parallel to that side. Okay, these guys are not parallel because if we extended these lines, they would eventually cross. So they're not parallel. These guys are. They would never cross if we extended them. Okay, as we said, the sum of quadrilaterals are 360 degrees. Whoops, that keeps coming up. We've dealt with that one. Yeah, in both cases, whether it's a convex or a non-convex parallelogram, they will, parallelogram, quadrilateral, they will always add up to 360. Doesn't matter what type it is. They've both got four angles, and those four angles will always add up to 360 degrees. Quadrilaterals with parallel sides include two pairs of co-interior angles. So like our trapezium, all right, this is a trapezium. Okay, it's like we've got these parallel. That's really poorly drawn. I'll try that again. Try and get a little bit better. It's a little bit better. Not much better, but a little bit better. Our parallel sides, and it's like we've got a transversal going through these guys. So if you look at it that way, we've got these interior angles, co-interior angles. And same on this side. We've also got co-interior angles here. All right, and that's important information to know. Okay, you can use that type of information. All right, hopefully that all makes sense to you. Yeah, okay, so just remember that last little bit that, yeah, when you got parallel sides, can include those co-interior angles. All right, so using that information, let's get into some examples. Find the value of the pronumerals in these quadrilaterals. So I want you to, again, pause the video and come up with an answer for these angles. So angle A over here and also angle A over here. And yeah, show you working out and pause it and let's see what you come up with when you get back. And I'm making very little sense. It's getting a little bit late in the evening. But anyway, pause it, have a go, and we'll catch up in a minute. All right, hopefully you've had a go. So let's have a go at these questions. So I forgot angle B over here too. I'm going to do angle B first because as we said in, where are they? Parallelograms, opposite angles are equal. Okay, so as you can see here, this is a parallelogram. We've got two sets of parallel lines, two pairs of parallel lines. Here, here, and then here and here. They are parallel. So that means that this angle and this angle are opposite. So angle B, straight off the bat, whoops, is going to be 77 degrees. All right. Angle A, again, we've got, if we look at it this way, we've got two parallel lines here. We've got a transversal that cuts that. So we've got co-interior angles. So in this case, angle A is going to be, co-interior add up to 180, remember? Okay, so the two co-interior angles will add up to 180. Whoops. It likes coming up, doesn't it? 180 degrees. So I'm going to say 180 degrees minus, I think that was 77 in there from memory, minus 77. Bear with me. I'm going to bring up the calculator again. I'm being a bit lazy with this, I know. 180 degrees minus 77 is 103. All right, so my angle A is 103 degrees. Okay, that easy. Over here we have a kite-like shape. Okay, but we can't use the information because it's not really haven't got the equal sides. These sides are all different. They're all different lengths. So these angles are obviously different. So we've got to use our knowledge of our four angles adding up to 360 to find angle A here. All right, so we know these three angles, 100, 115, and the box means that it is a right angle, so 90 degrees for that one. So we can use that information. So what I'm going to do is add all those guys up. I'm going to add 115 and I don't know what I'm doing 110 for. 115, 100 degrees and 90 degrees. I'm going to add all those guys up. So that's 5. Sorry, I'm not sure we understand what I'm doing. So 5, 0 and 0 is 5. 9 and 1 is 10. Carry the 1, 1, 2, 305. That's a really poor 3. These boards really don't like 3s. 305 degrees. And then all I need to do to find angle A then is to say, well, I know all the angles add up to 360. I'm then going to minus 305 degrees. So I know angle A is going to be 55 degrees. 360 minus 305 is 55 degrees. All right, and there we are on about 10 minutes. Again, we're being consistent with this, so hopefully that all makes sense. So using the different properties of the different quadrilaterals, you need to find the missing angles. All right, yeah, so that is it. Just very quickly though, I heard this someone talking the other day, and they saw this Clydesdale, and the Clydesdale gave a pony a drink of water, and they said, "Why did you give the pony a drink of water?" And the Clydesdale said, "Well, it was a little horse." Funny. Anyway, I shall see you in class. Bye-bye.